Hi, this is Mrs. LaBarbera. Today we are going to go over an example about how do we do lab questions. So here it goes. Experiment 1. A block of mass 1.5 kilogram is placed on a long board. You are to design an experiment to determine the coefficient of static friction between the block and the board. Part A. From the following list of available equipment, check those additional items you would use for the purpose of determining the coefficient of static friction. So you are given a list. Number 2, sketch a diagram of the experimental setup and label the pieces of equipment that would be used. Number 3, outline the experimental procedure you would use, including a list of quantities you would measure. For each quantity, identify the equipment you would use to make the measurement. So in order to do part 1, you really need to think about part 2 and part 3. Otherwise, you wouldn't know what to check, right? So there are different ways to determine this. In class, we have put the block on the incline and to change the angle of the incline so we can determine the coefficient of static friction. Over here, I'm going to show you there is another way. Think about another way to set it up. You don't have to put it on the incline. You can pull the block horizontally. Attach a block to the spring. Then you pull this spring gently, increasing your force. And when you increase the force such that block is just starting to move, and that is the force of the spring, that force actually equals to static friction. So if you set up like this, you would need a spring scale and a string. And your procedure would be set up as shown in the diagram. Gently pull the spring scale horizontally and increase your force until the blocks start to move. You need to measure that force with a spring scale. Part B, explain how to use the measurement in Part A, the previous part, to calculate coefficient of static friction. Include a free body diagram in your explanation that shows all the forces acting on the block while the measurements are being made. So that's in our experiment, this are the forces acting on the block. You pulled it with a spring scale, and there is static friction force. There's gravity force and normal force. In this case, we know all the forces cancel out because the block is just start to move. It's not accelerating. Net force in the x equals to 0, which is horizontal. Net force in the vertical equals to 0. In the horizontal equals to 0 means applied force equals to force of friction. And in the vertical means mg equals to n. We know Fs equals to mu s times n. Substitute everything together. F applied equals to mu s mg. That's how you find mu s equals to F applied divided by mg. And that's how you figure out coefficient of static friction. Now let's conduct a different experiment. Experiment number 2. In the second experiment, the coefficient of kinetic friction between the block and the board is determined to be 0.1. The board is now inclined at an angle 25 degrees above the horizontal. The block is released from rest at the top of the incline and slides 2.0 meters down the incline. Calculate work done by kinetic friction as the block slides down the incline. So let's take a look at our free body diagram. So here is the board. We have to measure this angle, and here are the forces. In this diagram, x would be going downward, that's positive, and y would be perpendicular to the board. So you can see the normal force actually equals to mg times cosine theta, because the theta between the incline and the horizontal and theta between mg and the normal are the same. So n equals mg cosine theta. So your friction equals to mu k times n, or become mu k mg cosine theta. Work done by friction is negative friction force times the displacement. By the way, this should be k. And it's negative because friction, displacement are always in the opposite direction. So the angle between the two vectors is 180 degrees, and cosine 180 is -1. We know what mu k is. We're given m, which is 1.5 kilograms. We know theta is 25. We know d is 2 meters. You simply substitute all the quantities in, and you will have 2.7 joules. Part D. The mass of the block is now increased without changing the coefficient of kinetic friction. In experiment 2, and experiment 2 is repeated. How does each of the following change? How does the magnitude of friction force change? Does it increase, decrease, or remains the same? We know friction equals mu k times n. If m increases, friction should increase. Next one, how about velocity? It reaches the bottom of the incline. How do we find velocity? We know in this case, the net force should be constant. So we can apply this kinematic equation to find a velocity. We know initial is 0. We know d is the same. So how does A change with mass? A equals net force over mass. Net force is mg sine theta. That's a component of gravity parallel to the incline minus force of friction. And as you can see in this equation, m cancels out. So A does not depend on mass. If A doesn't depend on mass, no other quantity depends on mass. So VF doesn't depend on mass. So therefore, the velocity remains the same. Number 3, kinetic energy of the block at the bottom of the incline. Kinetic energy is 1/2 mv squared. We know V is not affected by mass, but m is, right? So K will increase as mass increases. So the answer should be increase. That's it. I hope it helps. Thanks for watching. See you next time.